Hello again, it's Miss Denton, and this will be a very short video about SOL G11 Part B. Part B asks us to use angles, chords, arcs, tangents, and secants to solve real-world problems involving properties of circles, aka word problems. So let's check out a couple examples here. On the left, how many degrees are there in the central angle between 5 and 8 as you move clockwise? Okay, central angle. Let me get up here and find my information about central angles that we've talked about. What we know about central angles is that the angle and the arc are exactly equal to each other. This interior angle is exactly equal to the arc. Okay, so let's take a look. How many degrees are there in the central angle between 5 o'clock, there's 5 o'clock, and 8 o'clock as you move clockwise? So we're going this direction. All right, well, what do we know about clocks? There are 12 hours on the clock. So we could take our 360 degrees around the clock and split it into 12 pieces. 360 divided by 12 is 30. So each angle or each arc of the clock between the hours is 30 degrees of rotation. I think I can stop here because I think my point is pretty much made. So from 5 to 8 o'clock, 30 plus 30 plus 30 is 90 degrees of rotation. And remember, the central angle is exactly equal to its arc. So that central angle is also 90 degrees. It's a right angle in there from 5 o'clock to 8 o'clock. That's kind of a fancy way to ask you a question about the central angle of a circle. Okay. Our second example here is a little more wordy. Let's read through and make sure we understand. It says, a circular park is pictured below. The town council wants to build cement pathways to accommodate visitors. If the cost of concrete is $5 per linear foot, how much will this project cost? Okay, so something to notice. All of these represent sidewalks. We've got maybe 10 feet or 10 yards of sidewalk, 18 yards of sidewalk, 20 yards of sidewalk, an unknown amount of sidewalk. So I need to find the right formula that goes with this situation. These are definitely talking about the segment lengths in the circle. So I've got my segment page here. And if you just watched that video, you know there are 5 different segment formulas. So you got to find the one that matches what we're working on. And that is here, the intersecting chords or secants on the interior. So the pattern we use is that the part times part of one chord is equal to the part times part of the second chord. All right, so let's check that out. I'll write that out. Part times part equals part times part. So chord number 1, I'm going to call the 20 and x. So I'll have 20 times x is equal to chord number 2, ten and 18. So 10 times 18. Okay, 20 times x is 20x. 10 times 18 is 180. To solve for x, I need to divide by 20 on both sides. And x should equal 9. However, that's not my answer. Be really careful of what the question is asking. That's telling us that this is 9 feet or 9 yards long, some measurement of 9. The question says, if the cost of concrete is $5 per linear foot, How much will the project cost? So I need to pave all of this. I need to put concrete down on all of this. So how much distance is being concreted here? Let's see. Well, 20 and 9 is 29, plus 10 is 18. 20 plus 9 is 29, plus 10 is 39, plus the 18 more is a total of 57. Okay, that's all of this added together. And $5 per linear foot, 57 times $5 is $285. Not a bad deal for the town council there. So these are just a few of examples of how we can be asked these questions about circles in a more, quote, real life way. You do have to be aware of your formulas and your relationships in the triangle. Hope this helped you. Come back for more.